Morning, we are now looking into how we can use matrices to solve our linear systems, specifically those more challenging ones that have three variables. So to start things off, let's just get some vocab out of the way. A matrix is a rectangular array of our real numbers. So this is our matrix. We use these large brackets to group them. And so all of these numbers inside are called entries in our matrix. And the order, we give it by the number of rows times by the number of columns. So these are the rows, and these are the columns. So this particular matrix would be a 3 by 4. That would be the order for this matrix. Okay. And last piece of vocabulary, a square matrix would have the same number of rows as columns because it makes a square. So let's practice writing some matrix, and the plural is matrices, and we get the matrices, the values, the entries that go inside from the coefficients and the constants of our equations. So the first one we're going to look at is called a coefficient matrix, and this one is just from the coefficients of the system but does not include the constants. So if I was given this three equation system, if I wanted to write my coefficient matrix, I'm just going to take the coefficients from my three variables. Now, the important thing when setting up your matrix is that all of your coefficients for x, y, and z, or whatever your variables may be, are in the same column. So if I'm going to start out with my x coefficients, all of my x coefficients have to be in this first column, my y's in the second, and my z's in the third. So my coefficient here, remember when there's nothing, there's like an invisible 1. So that's going to be 1, -4, 3. Those are the coefficients for my x, y, and z in the first equation. Then my next one, -1, 3, -1. Then my last one, I have 2. Now, I don't have a y in this equation, so my coefficient for y is 0. And then -4. So that is our coefficient matrix, and if you look at my number of rows and my number of columns, this is a 3 by 3, which is a square matrix. So that's just our coefficients. Now an augmented matrix is going to have the same things as our coefficient matrix, except I'm going to have one more column with my constants that are on the right side. So for this one, all of my x's, all of my y's, all of my z's are in the same column. And then I'm going to take my constants that are on the the right side of my equal sign. And this is our augmented matrix. And this is a 3 by 4 matrix. And this is the one that we're going to be using more often to solve these systems. Okay. So first we're just going to start by writing the augmented and coefficient matrix for these systems in A and B. So on A, I just have a 2-variable system. So my coefficient matrix is just going to have the coefficients for x and y. So 4, -5, -1, 8. Again, I'm just putting my x's in the same column and my y's in the same column. And this is also a square matrix. Okay. Then my augmented matrix is going to be the same, except I'm going to add that last column with my constants from the right side. Oops, not -x, that should be -1. -1, 8, 10. And here is my augmented matrix. Okay. Then on B, again, I have a three variable system here with 3 equations. So my coefficient matrix is going to have 3 columns. My x, y, z, x, y, z, x, y, z. And again, this one is also a square matrix. And this is our coefficient matrix. Okay. Then our augmented matrix is going to be the same, except I'm going to have that 4th column with my constant. and that is our augmented matrix. Okay. So another thing we can do when we're given a matrix is we can write the system of equations that it was pulled from. So if this is our augmented matrix, we have that line drawn down the side to kind of indicate where our equal sign would be. So everything on the left is going to be our coefficients for the variables, and everything on the right is going to be our constants. So remember, all of our coefficients are ordered by the variable they correspond with. So everything here is x, everything in our second column is y, and everything in the third column would be z. So writing this first equation, I would have 1x minus 4y plus 12z equals 6. Then negative 1x minus 3y, no z, because I have a 0 there, equals 10. Then 14x, no y, minus 3z equals 5. And notice, you could just be putting these things closer together, but leaving that gap here helps to remind you that that would be a 0 in your matrix and vice versa. Okay. So now let's look at how we can actually use the calculator to solve these matrices. So in order to solve this in the calculator, we need an augmented matrix. So starting with A here, let's write our augmented matrix. Our x, y, z constant, x, y, z constant, x, y, z constant. Now, in my calculator, we are actually going to go to the matrix menu. If you see that blue word matrix above the x to the negative 1 power button, so we're going to hit second matrix, and we're going to scroll to the right to the edit menu, and we can just put this in matrix A. They're they're named by letters. So we need to type in the order of our matrix. Now remember, this is rows by column. So this matrix here had 3 rows and 4 columns. So this is going to be a 3 by 4 matrix, and it populates for you. So if you accidentally typed in the numbers wrong, you could just go back up and correct that. So we are going to type in these numbers into the calculator in the same position that they're on the matrix in our paper. So if I hit 2 for my first one, and when I hit enter, it goes to the next space to the right. So you can enter these pretty quickly by simply hitting enter. So 2, 3, 3, 3 for my first row. Then my next row is going to be 6, 6, 12, 13. Then 12, 9, negative 1, 2. So I have now entered all my values into the matrix, and I'm going to solve it now. So we exit out, and we're going to go back to that matrix menu, and this time we're going to scroll to the right to the math menu. And scroll down to that letter B where it says RREF, and hit enter. Then we need to tell it what matrix we want it to solve. So go back to your matrix menu, and when it says names, we're going to enter matrix A. Okay? And what it does here is it tells me when the coefficient for x is 1 and I have no y's or z's, my value is 0.5. So that tells me that x is 0.5 because all of my x's were in this column. Then the next one tells me if I have no x or z but 1 y, my answer is negative 1/3. And then lastly, no x, no y, no z, my answer, no x, no y, and 1 z, my answer is 1. So we look at the column, we had our x's here, our y's here, and our z's here. So this is our value for x, our value for y, and our value for z. And I'm going to write that as an ordered triple. So 1/2, negative 1/3, and 1. Those are my values for x, y, and z. Now let's practice this again with our example B here. X, y, z constant, x, y, z constant, x, y, z constant. So we're going to go back into our matrix menu, second matrix, edit, and we can put this one in matrix B actually, and we can keep matrix A. So this one's also a 3 by 4, and we're going to type in our values. Remember that you need to use the negative button when doing negative values and not the minus button because those are different. Okay, and then same thing, matrix math, RREF, and this time when we're picking the name, we're going to pick matrix B because that's where we've stored those values. And you'll notice something different here. In our first one, we had, our diagonal across of each of our variables, and here we have something a little bit different. We don't have that pretty, here's X, here's Y, here's Z. But what we do need to pay attention to is this bottom row is full of zeros. So this is kind of like when we're solving our systems by hand and we end up with 0 equals 0. So in this case, when I have a string of zeros in the bottom of my matrices, that means I have infinite solutions. Okay. Now, if instead of all zeros we had had like 3 zeros and then a number, that would be like our false statement and that would have been no solution. But when you get something that's not our typical answer, we just look at the bottom row, and if it's all zeros, that gives us infinite solutions. So now we're going to look at some applications that we can use our matrices for. The first one we're going to look at is finding the equation for a quadratic, which is like a parabola. So this was a typo, those should both be plus signs on step 1. We're going to find the equations by substituting our x and y values for the points we're given. We're going to solve for a, b, and c using our matrices and then plug them back into our quadratic equation. So in this first example 4 here, I've got 3 points, which are going to be my 3 x and y values. So again, we're using y equals ax squared plus bx plus c. So for this first point, y is 4 and x is 0. So a times 0 plus b times 0 plus c. So my first equation is going to be 4 equals c, because 0, 0, c. Then my next equation, I'm going to use the point 1, 1. So 1 is equal to a times 1 squared plus b times 1 plus c. So that equation is going to be 1 is equal to a plus b plus c. And I'm going to go ahead and highlight these so that we can distinguish which one is the equation that's going to go in our matrices and which one is the one where we're doing our work. And then lastly, the point 2, 10. So 10 is our y and 2 is our x. So a times 2 squared plus b times 2 plus c. And that's going to give me 10 is equal to 4a plus 2b plus c. Okay, so there are my 3 equations, and I'm ready to make my augmented matrix. Now remember, we want these in what we call standard form. So all of our variables go on the left and all of our constants go on the right. So these are actually written backwards. So if you want to make it more clear on what's going to go into the matrix, you could rewrite, okay, c is equal to 4, a plus b plus c is equal to 1, and 4a plus 2b plus c is equal to 10. So our matrix, no a or b on the first one, 1 of each on the second, and there's our third one, and we're going to plug that into our matrix calculator. Here it is on our matrix calculator, so we go to the Math tab, RREF, I put this back in matrix A, and I'm told, again, we had our A's in the first column, so that means that A is 6. We had our B's in the second column, so B is negative 9, and C is 4. So, oops, focus. So, again, we're putting this back into our quadratic equation. So we're going to take these values and substitute them here. So the answer we're actually looking for is that y is equal to 6x squared minus 9x plus 4. And that is the final answer for example 4.